All right, so for this free response question, so for t greater than or equal to 0, a particle moves along the x-axis. The velocity of the particle at time t is given by v of t equals 1 plus 2 sine t squared over 2. The particle is at position 2 at time t equals 4. So again, first thing I'm going to do is I'm just making my little chart off to the side. So I know v of t here, position, so it always goes position, velocity, time, position, velocity, acceleration. So x of t, and here we have a of t. So here, position, velocity, acceleration. This direction is going to be derivative. This direction is going to be antiderivative, so integral. And I'm going to circle where I'm starting, which for this one, it's giving me the velocity. So I'm circling velocity because that's where I'm starting. So it says the position is at x equals 2, at time equals 4. So I'm just going to write x, so position at 4, so x of 4 equals 2. You don't have to write that if you don't want. This one, so it says at time equals 2, is the particle speeding up or slowing down? So we know speeding up. So over here, speeding up, so I'm just going to write speed, means that velocity and acceleration, so v and a, have the same sign, right? So same sign. And I know slowing down. So if I slow, then that means here that v and a have different signs. So that's the immediate first thing I'm saying. Sorry, this is very messy. So v and a, diff sign. So that's what I'm thinking in my head immediately. So I need to figure out at time equals 4, what's my velocity at time equals 4. So all I'm doing is I'm just saying v of 4, and I'm plugging 4 in for t in my calculator. So in my calculator, I'm plugging 1 plus 2 sine of 4 squared over 2 straight into my calculator. And when I do that, I get, I believe, 2.978. So 2.978. And then the second thing I need to figure out is my acceleration. So my acceleration is going to be v prime, right? So the derivative of v. So I'm going to say v prime evaluated at 4, which is the same as acceleration evaluated at 4. And for this, you're just doing the math 8, putting this at x equals 4 in your calculator. For the AP test, you really would only need to write v of 4 equals this, and v prime of 4 equals a of 4, which equals your answer. So we're going to go ahead, plug that in your calculator. And when I do that, I get negative 1.16. So here, I see that they have opposite signs. So acceleration, velocity have opposite signs. So different sign means it's slowing down. It doesn't ask us to justify. So I can just write slowing down. If it said justify, we would have to say because velocity and acceleration have opposite signs, or because acceleration is negative, velocity is positive, any kind of justification like that. So slowing down. All right, next one. So it's saying find all times t in the interval where the particle changes direction and to justify your answer. So for this, for the particle changing direction, we know what controls direction. So direction is controlled by velocity, right? So we know velocity, so just as a note, so v greater than 0 means right, v less than 0 means it's going left. So what we need to do is we need to find all the times where it changes direction, so where velocity changes sign. So I'm going to take my velocity and I'm going to graph it. So 1 plus 2 sine t squared over 2. So I'm going to say 1 plus 2 sine here x squared divided by 2, like that. And it's only asking over the interval from 0 to 3. So I'm saying from 0 to 3, which is about here. So the only time it changes is right here at t equals 2.707. So I'm just going to say the particle changes direction. So the particle changes direction at t equals 2.707 because, and write out because and at, I'm just doing it because I'm so slow on this screen recording, but because velocity, so v of t, velocity changes signs. So the particle changes direction at t equals 2.707 because velocity of t changes signs. If you'd like to, you can say from positive to negative. All right, moving on to part C. So find the position of the particle at time t equal to 0. In order to do this, remember, if we want to find position, it's going to be, so x of t is going to be our original. So our original in this problem, if we look at it, we have at time equals 4. So our original time is at 4, and the position is 2. So what we're doing is we're going to say our original, what we already know, is x of 4, so our known, right? Plus the integral, so here our original is going to be 4 to what we're trying to find, which is 0 of v of t dt. So the known plus how much it changed in that interval. So we know our known is going to be 2 plus the antiderivative from 4 to 0 of v of t dt. And you're just plugging this directly in your calculator. And when you do this, you should get negative 3.815. All right. Last one. So I'm going to go ahead, erase this. And the last one is it's saying find the total distance that the particle travels from time t equals 0 to t equals 3. So remember, total distance or displacement is that, so integral from our interval time, so from 0 to 3, and displacement's the absolute value of v of t dt. And remember, with absolute value, the tricky thing is that we have to split it into multiple integrals. So the first integral is going to be, well, first thing we need to do is we're going to look at our graph for where the sign changes. So we already found that earlier in the problem, that the sign changes at 2.707. So what, t equals 2.707. So that's where I'm splitting my integral. So I'm going to rewrite this. So the positive parts of the integral, so from 0 to 2.707, so to 2.707 of v of t dt, and this, it's above the x-axis, so it's positive. And this second part, it's negative, it's below the x-axis, so we're going to subtract it. Because remember, if we computed this integral normally, this has negative area since it's below the x-axis, but we need everything to be positive, so we're just going to subtract it. So I'm going to say minus the integral from 2.707 to 3 of v of t dt. And from here, I'm just plugging this into my calculator. All right, apologies. I just realized I'm using a janky internet calculator, so I had to do this. You guys actually could have just plugged in the integral just like this into your calculator. To get those absolute value signs, you would just do, math, hit the right arrow once, and then where it says ABS, absolute, use that, and put in this exact expression, remember for v of t, whatever the expression for v of t is, into your calculator. And when you do that, you should get 301. So 301. So that should be the answer you get, 5.301. You could have done it this way as well. If you do it by hand, you'll have to do it like this to get that answer. So sorry I made that longer than needed. All right, moving on. So now you guys are just going to do a problem set on Delta Math for the rest of class. Feel free to email me if you have any questions, and let me know if you have any issues. Oh, and I did get rid of this one, so you guys don't have this one. Gratian wrote it was unnecessarily hard. So I did get rid of that one. You do have the rest.